Thank you.
Okay, now our next speaker is Kyler. Kyler is a senior principal engineer with SecureWorks and co-host of Angular Americas on Angular Nation. When he's not writing code, Kyler loves adventuring with his family, reading, CrossFit, and testing new Linux distributions. Wow, that's a lot. Kyler is going to talk about encapsulating logic with abstract classes. Take it away, Kyler.
Good evening, everybody. I'm
Good.
gonna share my screen here. All right, can everybody see that? Awesome. Okay, so like Julie said, I'm going to be talking about encapsulating logic in abstract classes. So the first thing I want to talk about is what happens as our applications and organizations scale. Our applications get larger. We get more and more implementations across our app. We have a lot of times many teams working on the same code base, all with different ideas of how things should be implemented. And the problem with that is you have different teams working in silos, and they all have this different idea of how something should be implemented. So the result is that there isn't a lot of consistency across teams as your organization and your application scales. That's a very difficult problem to solve. And I think in the landscape of front-end development today, Angular does a great job at being really opinionated and providing us with the tools to help with that. But there are some avenues that allows our code to become inconsistent. And outside of Angular's opinionated structures, we have things like services, which are, a lot of times that is the culprit that I'm talking about here. Is as our applications scale, we have services that accomplish the same thing in a multitude of ways across teams and organizations. That can be a challenge from a managerial perspective in terms of onboarding. It becomes expensive. It becomes difficult to maintain. And something I've learned in my career is that it's relatively cheap to build software. It's expensive to maintain it. So when we start talking about encapsulating logic and ensuring consistency across teams and organizations in the way that's implemented, it's important to talk about how that impacts the cost of the business. Cost of maintenance is an overhead. It is, and it's something that we should try our best to mitigate. In this talk, I'm going to talk about one way that we can do that. But first, I want to introduce myself again. I'm Kyler Johnson. I'm a senior principal engineer at SecureWorks, co-host of Angular Americas at Angular Nation. By the way, we have a Angular Americas show coming up this Friday at 10 a.m. That might be kind of early for some of the West Coast folks, but we'd love to see you there if you're an early riser. And we're going to be talking about Angular app conference applications, and we also have an app teardown feature coming up where we're going to talk about an app and how we might be able to do things differently and that sort of stuff. Also at Angular Nation, we're sponsored by AG Grid, the one grid that works everywhere with React, Angular, Vue, JavaScript, and TypeScript. It's the most feature-rich, enterprise-ready data grid available. So it's definitely worth checking out if you're in need of a data grid. You can find me pretty much everywhere at Kyler Johnson Dev, on GitHub, Twitter, LinkedIn. I am most responsive on Twitter probably. And of course, you can find my website at kylerjohnson.dev. So let's talk about what constructs Angular provides to us in its opinionated nature to create reusable classes that encapsulate logic. So a lot of these are familiar to us. We use them all the time, right? Pipes and directives, most notably. We're going to get into some of the pros and cons or limitations of these rather, and a lot of these limitations and pros are by design. to keep Angular developers implementing logic in an Angular way. So this is just a list of some of the things I'm going to talk about here. So the first I'm going to talk about is custom pipes. So this is a great way to encapsulate reusable logic in a class in Angular. This is one of the things that Angular provides to us for free, right? We get this out of the box. So anytime you need to format data in a performant way, Angular provides this really convenient API to help you do that and to keep you from hurting yourself and the performance of your application. So they intentionally limit this though, right? So you want to use pipes when you're formatting data in a template in your Angular application, but and you want it to be pure. It takes an input and it provides an output to your template when your Angular component gets built and creates that view definition. So this logic that is encapsulated in the custom pipe is the pipe is created it's an opinionated structure that Angular provides to you specifically for one purpose, and that purpose is to format data in a template. So custom directives, similarly, is it's another API that Angular provides to you specifically to help you modify the DOM, manipulate the DOM. So the opinionated structure here is that it directs the Angular developer to go about this in an Angular way. And we get a lot of things like this, like using host binding and directives instead of accessing element ref directly in our templates can do things like help us avoid cross-site scripting attacks, right? So there's a lot of there's security aspect to why Angular packs these directives in and things like host binding and host listening. But all of this logic is conveniently provided to us and is well documented, but it's for a specific use case, right? It's specifically for encapsulating logic that manipulates the DOM. So this is another great concept that we can reuse across our app, but only within a particular context, right? And I think that's a lot of these things as we go through are going to be that way. They have very specific use cases as part of Angular's very opinionated nature. So we're going to start getting outside of those things that Angular provides to us, and we're going to start talking about things that we need to implement ourselves and how we might go about that. So let's say we can use an interface, right? And we can kind of create this data contract, and we can talk about we can establish function signatures and members of a class and stuff like that. Anything that implements this interface has to implement these properties, right? This gives us a lot of great things, like we can polymorphically inject services. So if we want to trade, like one of the big benefits to something like this is let's say we have an old service we need to deprecate, we can create an interface for that service, stand up a new service, deprecate the old service, and the injector simply looks at this interface and we just provide the instance of our new service class to it. So that way that old service can still hang around as we get rid of it slowly throughout our app, right? And this contract just kind of helps us do that. But when in terms of talking about encapsulating logic and maintaining consistency, this helps with the consistency because everything that implements this everything that implements this interface has to implement all of the members defined in this interface, right? But the limitation here with this interface is that we can define function signatures, but not the implementation, right? So you might see there, we have in like this simple state service, we have a set state method and a patch state method. We have the function signatures, but the implementation can be vastly different, right? So in terms of the consistency of implementation, this doesn't really help us there. And in my career, that is one of the biggest problems I've seen. That is the area where I've seen the most inconsistencies across teams and organizations. And that is the purpose of this talk. So now that we've talked about the limitations of the interface, we can go to utility functions, right? So this gives us a lot of stuff. We can have, it has an input and an output, which is great. It keeps things pure. So we don't have to worry about mutably changing a variable outside of the scope of the function, right? We can use TypeScript generics here so that we can make this truly generic. So like an array, for this example here, removing duplicate objects by UUID, as long as it has a unique ID, you can deduplicate any array of objects there. So regardless of what that type is. So, but the limitation is that this implementation is pure, is self-contained. So if the implementation you need necessitates scope beyond this individual function, you're going to need a little bit more than this, right? So this is limited. It's great, but it's limited. Now we're getting to the service classes, and this is what I want to get to here. And I have a sample app to show that's going to illustrate this point a little better. But in here, we just have like a basic class. It's a Pokemon store. And this is going to be like, you can think of this as a global state store implementation. Let's say we're creating our own global state store, right? We're not really complex enough to need something like NGXS or NGRX, but we need some global state. So we start looking at ways to implement this. And let's say we know we're going to need other things, like I want to propose a Pokemon trade and allow other users to approve it or like view it, like, hey, I'm searching for a Lapras, right? And anybody want to have a Lapras they want to trade to me, and what would you want in return? Well, I'm going to need another store for that, right? For those sets of entities, because this one only handles Pokemon stores. So in thinking about creating this store and the type of logic that I need in a global store, a lot of that's going to be the same, right? You might hear this called boilerplate. There's going to be a lot of boilerplate code across all of these global stores that you're creating, store services as stores. So services are great because they're like the most powerful and the most versatile place to store logic. And unlike all the things that we've seen, there's virtually no limitations here. Like you can pretty much put anything in a service, and that again is another problem, right? So the big limitation with services, and this is what makes them reusing them very hard by themselves, is that you can't use TypeScript generics with them, with an injected service, right? So I can't say when I inject this Pokemon store or a store, I can't tell it at that time, at the time of the injection, that I want it to use this type. I can't use TypeScript generics with that. So what happened, I can make generic functions inside of the service, but the problem with that is it exists within the context of what the store is storing itself. So like in the Pokemon store, what's going to happen is eventually people, teams and organizations, as the app matures, people are going to start adding logic that is context specific, and that reduces the reusability of this, right? And it starts to merge in with that boilerplate code that needs to be consistent everywhere in the way state is maintained in our app. It starts to kind of spread into that, and you start to have this exception here where well, this function needs to work differently for this implementation, but this function named the same thing needs to work differently for this other state store implementation. And over time, consistency starts to go away. And as consistency goes away, maintenance costs go up. The readability of the code goes down. So what can we do to mitigate this? So let's think of an example. You're building a new feature, and you know what other places across the app will need similar logic. You want to make sure that the logic that you implement is consistent, can be consistent, and it's portable, meaning that whoever on your team or in your organization can use it, or who needs it can use it where they need it. So let's talk about what that looks like. Here's a really simple example of a base class. This can be a concrete class like you see here, or an abstract class. I like abstract classes for this. And the reason I like abstract classes is because it helps you restrict the usage of it. If, for example, this real class can be instantiated anywhere. So I can build this out and somebody can just inject it and start using it directly, when my intention was to make sure that services that need this functionality implement this or extend this, right? So, and the problem with that is people will start using this in unexpected ways, and that becomes difficult to maintain across different use cases. An abstract class, however, can't be instantiated by itself. So anybody who wants to implement that logic or take advantage of the logic that you've already written will need to extend their class. They'll need to derive a class from your abstract class. And that will give them access to all of the existing logic. So there are two things about maintaining patterns, enforcing consistency, and establishing implementation patterns. Is the first thing, you want to make it easy, right? If it's easy for your teammates, then they're much more likely to go with it, right? Because you're saving them time. And that's kind of what I talked about there. So let's dive into some code for a better example. And I know like what I've talked about so far is pretty high level. So let's get into some stuff here. But first, I'm going to show you what the app looks like. So just so you have some context. So I was a Pokemon nerd growing up. Still kind of like Pokemon, I'm not going to lie. It's a lot of fun, maybe nostalgia there. So I built a Pokédex here to kind of show what I have going here. And it's just basic. It lists all of the Pokemon. I think there's like 1,118 now, but who's counting? So yeah, you can see that there's a ton of pages here, but I'm maintaining the pagination state. There's Nidoqueen details. If I go back, I maintain the current pagination state across routes. So when I come back, I'm still on the same page. So now that you've seen this, it's pretty basic, but now that you have some context as far as what the app looks like, let's look at, I'm going to start from the top. So in the Pokédex component, I'm just injecting the Pokemon store, and it's just an observable, right? And of course, subscribing in the async pipe here. So pretty straightforward there. So let's head over to the Pokemon store. right? So this is where I've implemented the stateful logic for Pokemon. So I have an interface here. This defines the shape of my state, right? And this is the default state. So if you're familiar with NGRX, this would be your initial state in your reducer. This is going to be the starting point for this state store, right? So here, I have a store configuration object, and I'll get into that in a minute, and I'll show you why, where this comes into play and what you can do with it, right? So quite simply, I'm just loading state. So whenever load Pokemon is called, set state updates the, I use the set state method, which is I get from my base class here. And I'll go through these methods in more detail, but the point is set state is an important part of the state store. That would be boilerplate functionality, right? So that is provided by the abstract class at a lower level. So this class has no knowledge of it, doesn't need to. It just gets it by extending the state store base. So, and the rest is, it's just determining the pagination options, makes the call, gets the right page, and we subscribe here, and that's when we update state. And for the sake of brevity, I'm not handling the error here, but you should absolutely handle errors in a real life app. So at the end, I build the new state based on the response. I have some utility functions in here, like format Pokemon results. That's just taking the results that I get, and some of the limitations of the API, they don't provide the ID for you. So I grab the ID just so that I can get the images that you see. And this is where they keep those images in their repo. I just grab that ID and so that I can grab those images. That's basically what I'm doing here. So that, as far as what the state is doing here, loading Pokemon is pretty straightforward. I'm loading Pokemon, putting it in state. When this function is called, I'm updating state to say, hey, it's loading, so that I can add a nice loading indicator to my page, right? And then, of course, once it's done, I update state again with the response, turn is loading is off. So yeah, but all of the functionality that I need to do all of this stuff is all in the state base. So let's take a look at this state base and what that looks like, this abstract class here. So anywhere in my app that I want to maintain some state. So let's say I have global state, right? And I have a global state store for users. That service can simply extend this abstract class, and it can take advantage of the state observable that's already here for you, the state subject that maintains your or the global state for you. You can take advantage of the pluck state property, and you can get all these typings from it, right? So I can just pass in the key of one of the properties of my state object, and I get back an observable value of that state, right? That slice of my state object in a type safe way. And this is making use of TypeScript generics so that any service, no matter what my type is, whether it's user, whether it's Pokemon state, whether it's user state, whether it's trade proposition state, it doesn't matter, right? So, and I can even scope this to a component, right? If I want to maintain component level state that is tied specifically to the life cycle of a component, think something like NGRX component store, right? Where it's tied to the life cycle of an individual component, I can simply extend the component class with this, and I have all the same functionality there. in a consistent way. So, and that's the big thing here, right? This is consistency. Everybody's statement implementation, whether it's in a service, whether it's in a component, it's going to be implemented exactly the same way. So anybody onboarding, you want to know how state works in our app, you look at this one file and you know how it works everywhere. So let's take a look at, it's easy enough to stand up a state subject, state observable, and maybe add a few functions like set state and flux state, right? It's easy enough to just set that up everywhere you want it, copy and paste and change it up for your new implementation. But there's two things that don't necessarily lend itself to being maintainable. And the first is, whenever you're copy and pasting, even if it's a pattern you're copying and pasting across your app, inside of the context of individual stores, that code is still gonna like context specific operations are gonna creep its way in there. Doing something in an abstract class like this prevents that from happening. If you do need something context specific, right? That's fine. You can do it in the Pokemon store, but that doesn't, at this point, that doesn't affect the implementations across the app. That doesn't change the core functionality of state services in your app. So let's take a look at one of the more powerful things that this can provide to you, and it's taking advantage of the legwork that others have already done. You don't have to copy and paste this. You don't have to figure out how this is going to work for your implementation. It's already done, right? So here in my app, you see that I have a blank console, right? And I'll refresh the app so you can see that nothing there. So let's say this state isn't working quite like I had hoped, right? Something is wrong. I need to figure out what. So in my base implementation, I've created a series of logs that will log some things for me and tell me what's happening. So on the first level, and let me make this bigger so you can see it. Is that better? So there's a couple log levels here, right? I have just a basic debug level and a verbose level. This is the basic debug level you see here. So we can see as the page loads, we can see that it's setting the initial state in the constructor. The state was updated, new state, some new state was emitted, new state was emitted again, and the state was updated, right? So we know that all of these things happened. So, but what if we need a little bit more detail, right? What if I just add the verbose option to this configuration option? And I'll show you where I'm implementing this again in just a second. But now when our app reloads, we get a lot more information, right? So now I can go in here and I can say setting initial state, and this is what that initial state looked like. I can, and then I'm doing a diff on the previous state to the new state. So I can say when the state was updated here, is loading was set from false to true. So I know that that's where we were making the call, right? Load Pokemon was called. State was updated to reflect that it's loading. And then a new state emission happened, right? And that's because is loading is true. That way we can provide a nice little loading icon for the user there. And then a new state emission happened and this happened when our response came back, right? And we can see is loading went to false. This is the new state emission, right? So this is what we expect to see when our response comes back successfully. We see all the populated Pokemon, and down here we see the state was updated, and this is the diff, right, from that you get in the set state method. So I can see here that state was updated. Is loading went from true to false, the Pokemon property went from null to populated with tons of Pokemon, right? And I can just go through the app and debug this way. And part of the power is nobody has to implement this again. Nobody has to debug this, right? Anybody who wants to implement this logic, they're standing up a new user store. They just extend this class and they have all this power at their fingertips. They don't have to go figure out where to put these log statements. They don't have to. I've already provided a convenient way for them to debug, to see into how the state implementation is working, what's changing, and when. And all they have to do is pass in a debug option and a verbose option if they want to see more detail. So now I've provided a convenient API for other developers on my team and in my organization to implement a global state store or state logic, and I've provided them with an easy way to debug it. So so I've done a lot of the legwork for them. One thing I just want to go back to here is this is the Pokemon store, and this is the configuration object, right? And I've got a type for this defined in my state base here. So it's of type T. Initial state is whatever of type T. It could be user state, it could be Pokemon state, it could be trade proposition state, right? And debug and verbose are both optional. So you don't have to have that turned on, but you can. So then I just expect that in the super constructor of the derived class, that you pass in this configuration object. The only thing that is required is initial state, right? Because we need that in order for it to work. So if I go over to my state base and I look in the constructor, we see that I have a state subject declared but not initialized. I have a state observable declared but not initialized. When I pass that configuration object into my constructor here, that's where I do a lot of that legwork. I figure out if they want to debug and if that debug is verbose or not. I figure out what to say based on the log level they've indicated. And I take that initial state value and essentially cache it in the service, because if they call reset state, it's going to go back to this default state. So I need to keep that encapsulated here. But this is where I initialize that behavior subject with the initial value, right? Because a behavior subject has to be initialized with an initial value, and null just wouldn't work very well for our use case here. There's too many side effects that could come from a null state. So our default state is set there. This is similar to the way NGRX handles a reducer with its initial state. And then of course we initialize the observable, and you can see a lot of places in here where I have if statements checking the debug level and how we might do that. So just a cool side tip, you may have noticed that the console logs were a different color, just stand out so that it's not just a wall of text with any other console logs that might be in there. I've just kind of found that helpful if I'm trying to provide hints to other developers on my team. And you can do that with like where is it? It's a %C there at the beginning of the string. And then you just provide the color as a second argument. So, but yeah, that's kind of, so I'm going to go back to my slides just to kind of keep myself on track here. But the key takeaways here is that Angular provides us with a lot of great ways to reuse logic in our app, but they're not fail-safe, and they're not they're opinionated, right, for very specific use cases. That isn't going to always line up with our needs. So it's up to us to ensure consistency in our implementation. And that's a big part of maintainability. I mentioned earlier that building software is relatively cheap, maintaining it is expensive. In doing this type of legwork, like I did with an abstract class here, providing a set of providing a set of APIs that are easy for your teammates to implement, easy for your teammates to understand and debug, is an important part to ensuring that you can maintain consistent implementation patterns across your team and organization as it scales. And that will help mitigate the cost of maintenance costs and protect your sanity. So an abstract classes is just one more tool that you have to help with that. So again, I'm Kyler Johnson. You can find me at Kyler Johnson Dev pretty much anywhere. If you want the repo for the sample app, there's a QR code here. So I'll just leave that up for a minute. So anybody that wants it can scan the QR code. And that's all for my presentation. If there are any questions, I'd be happy to answer them.
That was a really great talk. Thank you so much, Kyler. We had one question, and Ankita did a great job of answering it already, but just in case, just more for the recording, the question was, what's the difference between extends and implements?
That is a good question. So let me think about a way to explain this. So sometimes it's kind of hard for me to think about things in terms of TypeScript OOP, because a lot of these concepts I learned in C#, where there wasn't much of a difference between them. So it's and you kind of get into a little bit of the TypeScript internals, right? So
I can read what or Ankita, if you actually want to say what you wrote, just to again,
yeah. It's still the same, even though no matter which language it is, it's still the same, because what Keller was showing was abstract classes. And if you're extending it, you would get the base functions that he had defined in it, the base methods that he defined in it by default. You don't have to implement them. You don't have to provide your own definition for them. You just call super and you get that. But if you implement something, and you would usually implement an interface, and if you implement it, then you have to provide your own definition for the methods or the properties that would be defined in the thing that you're implementing.
That's kind of what I was talking about, in the difference in the way inheritance works in TypeScript. Most other languages are like C#, for example. You just inherit from it, and and it has this concept of overriding, right? You can override whatever you need. But TypeScript doesn't really have that, because the concept of overloaded methods can't really exist in a transpiled language, a language that is transpiled to JavaScript, where that construct doesn't exist. So yeah, implementing it is more of what you would be used to if you're a C# dev and you're implementing an interface that requires that implementation, where the derived class requires that implementation. But if you but extending it is kind of like what you would expect in a base class, to where you can make use of them. They're there, all or none of them, or just a few of them. But yeah.
Awesome.
Thanks, Ankita.
Cool. Are there any other? Oh, great. Alex's question says the state management is a lovely and intuitive use case for abstract classes. I'm kicking myself for not using it in one of my past code bases. Aren't we all? Can you think of any other good use case / examples where you might want to use an abstract class on a service?
That's a good question. So, you know, if you have a service kind of like a logger, you can, let's say you're logging to a remote server somewhere and you're keeping track of those logs for auditing purposes, maybe. And you might have to, you might have different log levels to configure and stuff like that. You could write an abstract class for that and then inherit in places in like different types of loggers. And what that would allow you to do is if you're logging to multiple places, like to a console or to a remote server or something like that, you could do that consistently between the different implementations. But and the abstract class would take in an argument, a generic or whatever, but that says this is where it's going, and this is, you know, we might need these credentials to send this across the wire or to authenticate with this server that we're sending them to or whatever. So you can potentially use it for something like that. Basically any logic that multiple services will need to implement or many services that need to implement where consistency will be important. So this pattern is not for everything, right? It would be easy to go crazy for this, like, hey, these two services are going to have like the same method, we should create an abstract class and both of them, and it can inherit from both. Well, like, there is a cost to this, right? So, and that cost is when you're writing tests for whatever implements this, now you've got to look at two classes to figure out how your tests are going to need to work and provide value. So it becomes a little bit more difficult to test derived classes. So you want to make sure that the benefit you're gaining from enforcing consistency with an abstract class exceeds the level of complexity that it brings, right? So, and I'm not sure that the logging example that I provided quite fits the mold there.
So another example, Kyler, that you were mentioning was for like an HTTP service.
That's another good one. So like if you have an HTTP service and you want to, you know, every service needs to implement a you know, your basic CRUD operations, right? You can put that stuff in an abstract class, and you can even, like, even if you have a map or like you need to map the results or something like that, you can even add arguments to that, an optional argument to those methods to you know, query a JavaScript function over there to map the results the way you need or whatever. You can make that generic and say that all of your HTTP services are going to implement are going to have these things. And depending on your implementation, you might find the value in that. Just kind of depends on your implementation.
Kyler, can this be used for like when, let's say that I have you know that when you're using Angular, you create a service and then you have like about 10 or 20 different calls to different APIs and things like that, you know, in a big application. Instead of doing that, we can probably put it in an abstract class and then get all those. So we just have to pass it maybe just the actual API URL and then perform those other CRUD operations.
Yeah, you could definitely do that. But you just want to make sure that the value you're gaining from this exceeds the level of complexity you're introducing with it, right? So you know, you can kind of get into the weeds there because you know, all of your you can provide you can say that, hey, this service is going to return a generic type, and you can define that type kind of like I did in the state store, right? But like there are gonna be times where you're gonna need to modify the results, or map the results, because you might have certain derived properties or whatever that you need to establish on the object, and that sort of stuff. So you're going to have to provide a generic way to map those results, and across a big application, that's just going to happen, and it can be difficult to do that in a way that is generic enough to fit all of your CRUD operations. So I can see that becoming difficult to maintain. And I'm not sure that this provides quite the value for that use case. I'm not sure. I'm not saying that it won't, but I'm not sure. I haven't done it and I haven't used it in that sense. So I'm just trying to think of CRUD operations across a large app is often different based on the API. Some might be REST, some might be on the old REST endpoints, some might be using new GraphQL endpoints. So you would have to handle both GraphQL and GraphQL queries and REST endpoint queries, or some of the results you get back from a server might be inside of a results wrapper object. Some of them might just give you raw results in the response body, right? So handling all of those types of different cases in a generic way, you might end up writing more code to handle all of those cases than this would save you. But a lot of that depends on how consistent your backend team is with, or you if you're writing APIs in a full stack environment. But it depends on how consistent the format of the data you're returning is.
I know this is an Angular meetup, but I love to use abstract classes and patterns like this. One talk that I saw that actually helped me like kind of think about like when to use an abstract class and when is it okay to just have that duplicate code. It's a talk by Dan Abramov, who's really big in the React community. It's called I'll find it. It's in like wet code bases or something. It's basically like the opposite of dry, but he gave a really good talk about like sometimes when you try to use abstract classes too much and then you just like create this monster class, and you don't want to do that. So I'll put the link there because I think it was really helpful to kind of think about when is it good to use abstract patterns and when is it not. Because yeah, totally agree with Kyler. It's super useful, but you can definitely overcomplicate things if you don't use it at the right times.
Do we have any other questions for Kyler? Yeah, that was amazing. I learned a lot. And so I look forward to poking around your repo, checking it out.
Awesome. Thank you.
Yeah.
Really great talks tonight.
Excellent talks.
All right. Well, thank you everyone so much. I'm going to stop the recording.